It started as nothing more than a flicker, a barely perceptible whisper in the vast sea of cosmic data. A cold, silent speck, hurtling through the void at speeds that defied conventional astronomy. Observatories from Mauna Kea in Hawaii to the South African Astronomical Observatory in Sutherland picked it up first, their automated alerts flooding global networks almost simultaneously. Within hours, NASA stepped forward to confirm the anomaly, an unregistered, unknown object originating from beyond our solar system. At first glance, it resembled just another interstellar rock, a wandering traveler from the interstellar medium. But as data poured in, the anomalies began to accumulate like dark clouds on the horizon. Its velocity was staggering, over 152,000 miles per hour, far exceeding the escape velocity of our solar system. Its trajectory was unnervingly precise, slicing through the ecliptic plane with mathematical elegance as if plotted by an invisible hand. And its albedo, the way it reflected sunlight, was anomalous, gleaming like polished metal rather than the dull, pitted surface of a typical asteroid or comet. When astronomers backtracked its path through the darkness, using sophisticated, orbital simulations, they realized it wasn't merely passing through. It was on a direct intercept course with the inner solar system, threading the needle toward the beating heart of our planetary neighborhood, the region encompassing Earth, Mars, and the asteroid belt. The James Webb Space Telescope, JWST, humanity's most advanced eye in the sky, was swiftly repositioned. Launched in 2021 and orbiting at the L2 Lagrange point, JWST's infrared capabilities pierced the veil of space dust and distance. What it revealed was not just unprecedented, it was paradigm-shattering. If this wasn't a natural visitor but something engineered, something watching us, the very definition of deep space exploration might change forever. Between June 25th and June 29, 2025, the Asteroid Terrestrial Impact Last Alert System, ATLAS, a network of telescopes designed to detect near-Earth objects, locked onto it definitively. The mysterious interstellar interloper was provisionally named 3I Atlas, marking it as the third confirmed interstellar object, following Oumuamua in 2017 and 2I Borisov in 2019. But unlike the countless icy wanderers catalogued from the Kuiper Belt or Oort cloud, 3I Atlas defied every expectation. It hurtled inward at velocities suggesting a millennia-long journey from deep interstellar space, a region so remote that its origins could trace back to another star system entirely, perhaps Proxima Centauri or even farther, in the direction of the constellation Lyra. The timing alone raised eyebrows. Before 2017, humanity had never detected an interstellar object. In the 8 short years since, we'd encountered 3, each stranger than the last. Oumuamua, discovered by the Pan-STARRS telescope in Hawaii, was cigar-shaped, roughly 400 meters long, and exhibited non-gravitational acceleration, speeding up without visible outgassing, as if propelled by an unseen force. Skeptics attributed it to hydrogen ice sublimation, but Harvard astrophysicist Avi Loeb famously speculated it could be artificial, a light sail or probe from an extraterrestrial civilization. Then came 2I Borisov in 2019, spotted by amateur astronomer Gennady Borisov in Crimea. It was more comet-like, with a volatile composition and a hyperbolic trajectory, but its speed and organic molecule signatures hinted at exotic chemistry from another stellar nursery. Now, 3I Atlas combined the enigmas of both predecessors while introducing new puzzles. It was brighter than expected for its size, with JWST's near-infrared spectrograph, NIR spec, revealing a surface reflectivity of over 0.8, comparable to fresh aluminum foil, not the 0.1 typical of asteroids. Yet radar scans from the Goldstone Deep Space Communications Complex estimated its diameter at a mere 150 meters, far too small to account for its luminosity unless it was unnaturally smooth or metallic. This contradiction suggested a manufactured exterior, perhaps a thin shell of advanced metamaterials designed to withstand interstellar radiation and micrometeorite impacts. Avi Loeb, ever the provocateur, weighed in publicly via a preprint on archive.org. Look for non-gravitational acceleration, he urged the astronomical community. If it's propelling itself without outgassing, That implies intent, technology, not nature. Loeb's breakthrough, Listen initiative, funded by billionaire Yuri Milner, redirected SETI, search for extraterrestrial intelligence radio telescopes like the Green Bank Observatory to scan 3I Atlas for technosignatures, narrow-band radio signals or laser pulses that could indicate artificial origin. From the outset, 3I Atlas appeared as a cosmic hybrid. It mirrored Oumuamua's inexplicable acceleration, deviating from a purely gravitational path by about 0.1%, and Borisov's inbound comet-like trajectory, yet it fit neither category neatly. Its rotation was eerily symmetrical, a stable spin every 4.2 hours without the chaotic tumbling of natural fragments ejected from a distant star. JWST's mid-infrared instrument, MIRI, detected asymmetric heat distribution, one hemisphere consistently absorbing more solar radiation than the other, as if shielded by a thermal blanket engineered for long-duration spaceflight. Even more intriguing, MIRI picked up a faint, constant thermal signature. Structured infrared emissions at 10-15 microns, not the random blackbody radiation of a rock, but patterns reminiscent of electronic waste heat from onboard systems. Then came the bombshell. Orbital data from the European Space Agency's ESA, Gaia spacecraft, which maps stellar positions with exquisite precision, showed 3I Atlas adjusting its course in small, precise increments, microthrusts of mere centimeters per second squared, without any detectable jets of gas, dust, or plasma. This wasn't the Yarkovsky effect, sunlight nudging a spinning body, or solar radiation pressure on an irregular shape. It was active steering, implying propulsion technology beyond our current ion drives or chemical rockets. Could it be an antimatter, engine, a warp bubble, or something more exotic like manipulating space-time itself? Spectral analysis from NASA's Goddard Space Flight Center in Maryland shattered remaining naturalistic assumptions. Using JWST's data, spectroscopists identified carbon-based compounds in complex arrangements, fullerenes and graphene-like structures, far more ordered than in natural geology. These were consistent with advanced composites used in human spacecraft, but scaled up, perhaps carbon nanotubes woven into a hull for strength and lightness. Electromagnetic fluctuations detected by the Very Large Array in New Mexico hinted at internal compartments, layered Faraday cages or superconducting coils, possibly for quantum computing or energy storage. Doppler shifts in reflected radar suggested hollow voids within, reducing mass while maintaining structural integrity. This was no mere lump of cosmic debris. It was a machine, a probe, a scout, or worse, a sentinel. At this point, whispers began circulating among scientists across continents, amplified by secure channels on platforms like Slack and encrypted email lists. Conferences like the International Astronomical Union, IAU meeting in Busan, South Korea, buzzed with off-the-record speculation. Who had sent it? An ancient civilization from a dying star, seeding the galaxy with von Neumann probes, self-replicating, machines that explore and report back, or something closer, a relic from a Kardashev Type II society harnessing their star's energy. And why now? Was it drawn by our radio broadcasts, the Voyager probes, or the recent uptick in exoplanet discoveries? Via telescopes like TESS and Kepler, the object's projected path added urgency. Simulations from the Jet Propulsion Laboratory, JPL, in Pasadena showed it slingshotting around Jupiter in late 2026, using the gas giant's gravity to decelerate and enter a stable orbit near Earth by 2028. Close enough for detailed study or interaction. International collaborations ramped up. China's Fast Radio Telescope joined the hunt for signals, while India's AstroSat scanned for X-ray anomalies. Amateur astronomers using backyard setups linked via apps like Unistellar's network contributed real-time tracking data. But then, without warning, the information flow halted. Agencies that had been transparent, NASA, ESA, Roscosmos, abruptly sealed their data behind classified networks. Public databases like the Minor Planet Center froze updates. Observation logs on platforms like Astrobin went dark. Even telescope time allocations for independent researchers hit technical restrictions, with vague excuses about calibration issues. Journalists from outlets like the New York Times and BBC, probing for answers, received redacted FOIA responses and boilerplate statements, ongoing analysis to ensure accuracy. It smelled like damage control, not science. This sudden blackout ignited a firestorm online. Conspiracy theorists on Reddit's Are UFOs and X, formerly Twitter, exploded with theories: government cover-up of first contact, alien invasion prep, or reverse engineering efforts at Area 51. Leaked memos, unverified but plausible, suggested high-level meetings at the United Nations Office for Outer Space Affairs in Vienna, discussing protocols from the 1967 Outer Space Treaty. Was 3i Atlas emitting a signal we couldn't decode? Or had it already phoned home, alerting its creators to our presence? As tensions mounted, a coalition of scientists led by Loeb petitioned for transparency. If this is artificial, Loeb argued in a viral op-ed, hiding it risks global panic. Disclosure could unite humanity. Meanwhile, private ventures like SpaceX and Blue Origin quietly launched observation missions. Starlink satellites repositioned for flybys and Prototype Pro.